reason to have a big problem with numbers, because numbers as they're used in classical and modern mathematics are unrepresentative of nature.
Okay.
In other words, they do not they are abstractions from nature that fail, and they really do fail in a whole variety of ways to express or represent natural dynamics and natural flow. And there's a really good reason for that.
Can I ask questions?
Yeah.
Why is nature being associated with numbers? To me, that doesn't make sense.
Because, well, what you're saying is you have a problem because the idea that nature can be quantified,
yes,
numerically.
Yes, I just
you
can't accept
have
that.
a really big problem. You can't accept that.
Yeah.
And I'm agreeing with you.
Oh, are you?
Yes.
Oh, okay.
Okay, so that's the first and really important
clear communication go between us there. Yeah.
is
Okay,
that nature cannot be represented, but nature cannot be quantified numerically.
Right.
Okay, but and that's right at the heart of the difficulty that we have with the application of classical and modern mathematics to natural process, to natural form, indeed to our humanity.
Right.
So the question is that now we've got to fly buzzing around the room, but maybe you will add a little buzz to our situation. We can ask the question: is why do so-called natural numbers? Why are so-called natural numbers, as the mathematicians call them, unnatural? Yeah, primary numbers or. Odd and even numbers going from 0, 1, 2, 3, 4 and all the rest of it. Why are they unnatural? But we can also ask the question of, could they be natural? And could our use of numbers actually be more naturally representative and so lead us into a kind of mathematics which is actually more representative of natural process and of humanity? And this is the real issue that I'm talking about, because as we all know, mathematics and the logical principles of mathematics are dominant in the world that we live in, and it's one of the right reasons that we all find the world a difficult place to live in, especially those of us who see through that quantification, numerical quantification. Now, the way I'll just try to illustrate this for you very quickly is mathematicians often represent numbers as a natural progression of getting from small to big, and they represent that natural progression as a line.
Right.
Okay, and the line begins at a point, and it extends. So it begins at a point. This is remember, I'm talking about conventional mathematics at the moment. Yeah, it begins at a point and stops at a point. Yeah, and and numbers are represented as stopping points along this line. So we can have 1, 2, 3, etc. As stopping points along this line, and we arrive at a point, and the only way of extending the line is to extend it and go to another point. And this is really difficult because ultimately you've got a big problem with the concept of zero,
right,
and a big problem with the concept of infinity.
Right.
Because if you've got zero there and infinity somewhere over here, you somehow got you've isolated
edge of the cube.
Well, essentially, yes, you've isolated you've excluded the zero and you've excluded the infinity as beyond the limits of this defined line. Right. Okay, so in other words, you can never reach infinity. Because you can only extend the line.
That's right. Yeah.
And you can never actually either reach zero.
You always reach minuses.
Because you just get smaller and smaller and smaller in what is, forming. I've forgotten what the word is, but anyway. But you just get hyperbolically smaller.
Yeah.
So you can't actually attain zero, you can't actually attain infinity, but you use these concepts of zero and infinity all the time
Yes,
in mathematics,
Yeah.
but they're paradoxical.
Yeah.
Okay, so that's our big problem, and what we have here is a major problem of continuity, is that numbers represented as points, along a line, and of course number 3 is really a segment of the line between 0 and 3,
Right, yeah.
and 4 is, so that we're getting this linear progression. It's also, notice, only one way.
Yeah, it's not.
It's not working. It's only working from small to big. It's not
Yeah.
working in the opposite way. So we've created numbers, and the basic idea is we represent numbers in this way. Now this is representing numbers as purely informational.
Right.
Okay, so essentially the whole of mathematics is built, purely on the explicit. The matter that counts makes numbers, and the implicit is excluded.
Sure.
It's outside the frame of reference of the explicit. So essentially that's right at the heart of the fundamental paradox of conventional mathematics.
Right.
And the way that conventional and modern mathematics try to deal with this was by cheating.
Yeah.
By means of taking a natural curve and cutting it into bits, and then adding them all back up together again. But there is no real continuity in classical and modern mathematics. And there is no flow. Because there is no continuity, there can be no flow.
Okay.
Yeah?
Yeah.
So, how might one deal with this? And this is where the really exciting kind of idea arises, is, well, actually we can deal with it by including the implicit in the explicit, so that we actually now make the implicit or non-local aspect of nature, an inclusion of, the explicit aspect. So we, if you like, we combine the explicit and the implicit. We bring the zero inside the line. We bring the infinity inside the line. Yeah?
Yeah.
Instead of having them outside these limits, we bring them inside.
Wow.
Now, a very simple way of thinking about this is if we're just thinking about a point, in classical Euclidean geometry, a point is dimensionless. Yeah, it has it because it's dimensionless because it includes no space.
Oh, sorry. Yes. Okay. Yeah.
Okay, it's a dimensionless point.
Yeah.
And in classical thinking, and that arises because you've excluded the dimension. The dimension is the space. You put it outside. So the question is, how can you convert this dimensionless point, into a dimension full point? You do it by including the space.
Okay.
You do it by effectively converting the point into a sphere.
Yes, which I did instantly.
As you did instantly.
Yeah.
Exactly. And as any child would do, because the idea of something that has no dimension is very obviously and clearly an abstraction. And we've built the whole of our thinking on such abstraction. Yeah, so we start thinking instead of instead of having these stopping points which are dimensionless, we have dimension full points which we can represent, if you like, as what I call a sphere of influence. And when we're thinking about this sphere of influence, let's actually think of the space as all the whiteness here.
Yes.
Yeah. So when I simply draw this sphere here, which is of course in the plane of the paper, it's only a circle, but you have to imagine it as a sphere. It actually has an inner world. It has an outer world. There is the non-local, which is throughout, and the local, is merely the somewhere distinct. Yeah.